everyone. So my name's Kevin Harris, and I'm one of the co-founders of Radiant Fabrication. And when we started Radiant back in late 2011, I had very little experience developing with hardware. My background is in education and software. And so what I wanted to talk with you about today is some of the differences between developing for hardware and software, and try and give you some numbers to make that more concrete. So, when those slides automatically advance. Okay, great. So Radiant Fabrication, for some context, is developing a 3D printing pipeline. So everything from modeling the object up to printing it on our hardware. And if you're not familiar with 3D printing, the most common technology takes a 3D model from like a CAD program or something, and it slices it up into individual layers, and then it deposits plastic to build up the final object layer by layer. Now, there's a few reasons this is interesting. One is it lets you create things like that, interlocking gears that aren't possible other ways. And two, it scales to really small volumes of manufacturing. So when we started prototyping our hardware, it was really inexpensive. In our first 11 months, we spent $6,000. And there's one reason why we could do this. And that's because we established a relationship with a local university research group, and they gave us free access to a printer like this, and they also gave us a fully equipped machine shop. It was great, but all things that are good come to an end. And when we started to develop our more robust production-ready components, we had to bear the burden of that cost ourselves because we'd lost access to the machine shop and the 3D printer. So with our parts now, it costs us about $1,000 to print a complete set on this same printer. Now, there are other costs as well if you're developing for hardware, and the most important one is that you have patents. And patents are a touchy subject in software development, but if you're trying to get investments for hardware development, you absolutely need to have them. And if you're a student or if you're an employee of a company, your university or company probably owns anything that you create. And that's great because they'll pay for everything. But on the downside of things, that means they might not license it back to you. And that happened to us, actually. And so in that case, what you need to do is talk with your own lawyer and come up with more IP. And you'll expect to pay at least $7,000 for that entire process. And that means you're also going to be doing the research of existing IP on your own. Okay, so software is cheap, hardware is expensive. Hardware is also really slow to develop. If you're ordering parts, you should expect them to arrive in a day or two, and that's not too bad. But if you have to print something, like on this high-end 3D printer, you should expect to wait a while. Printing our parts takes about 110 hours, and that's not including 24 hours of post-processing time. So it takes a while. But you don't need to 3D print everything. If you can use a mill, that's great. I hear there's a hackerspace over there. They probably have a mill. Use that way. Thanks. Okay. When we were prototyping, we used a manual mill for about $100 a month, and it would take us about 4 to 6 hours to make our parts. If you get a CNC mill like this, you can probably do that in 25 minutes. Those are $7,000 and up. So hardware is expensive, and it takes a long time to make things. But luckily, you get to develop hardware, software, and any firmware simultaneously because you're trying to meet aggressive goals. And that really sucks. But much like developing software, integrating all of these components is interesting because you're going to get new kinds of bugs that you're not familiar with, probably. If your background is primarily in software, you get to experience things like circuits being bad and components failing. And that's not something that I saw very much doing application development. So ideally, you'd want to keep one thing constant and focus development on that while keeping everything else at a stable state. But again, you can't do that. So automated testing is essential for both software and hardware. And then automating any process that you ever have to do more than once is incredibly useful. The last thing that's very, very helpful is developing a relationship with your manufacturers. We've had a lot of support from Parallax Semiconductor, which provides our microcontroller. And without their help, we would not have tracked down some very, very obscure bugs. Okay, so if you're not scared of developing hardware, then great. There's a few things you might do. If you don't have an electronics background, there's a great book called There Are No Electrons by Ken Amadal. It's a very accessible, easy to read introduction to electronics. And then also, it's imperative to develop something on the side, even if you're not directly working with the hardware, because then you can think about those bugs. And with some hard work and a little bit of luck, we'll all reap the benefits of your inventions. Thanks.